Is my can empty or full?
Empty. Full.
What the hell?
What's it full of?
There.
Good. You remember from last time I was talking about the air. So we had one demo already this year where I did the water balloon, trying to put it in the bottle. This is going to take advantage of the same idea, just going to illustrate it in a different way. People forget how much air is stacked on top of us right now. You're used to it your whole life. You don't even notice it unless the wind happens to be blowing really, really hard, or you're driving down the highway and you stick your hand out of the car and you can feel the wind pushing. But all of that air on top of us has a significant amount of mass, okay? And when you start to look at how pressure operates, or sorry, how air operates, it's all about varying amounts of pressure. If you think back to when you were talking about the kinetic molecular theory, that is solid versus liquid versus gas, what's the big difference between those three? How far apart the particles are and how fast they're moving, okay? So what I'm going to do in this demonstration is I'm going to take a little bit of water and put it into our can, okay? And this is going to help keep the can from burning on the bottom when I set it over the Bunsen burner. It's also going to let me know when the air inside this can has been significantly heated, okay? So there's a finite number of particles inside the can right now. There we go. So I'm going to start heating it up.
Can we turn up? Oh, never mind.
There's no need for lights on this one.
Okay.
So right now, the particles of air inside the can are receiving that thermal energy. They're getting their own kinetic energy, and they're moving around faster and faster, and they're getting more and more of a space between each of the particles. As that happens, some of those particles are leaving through the top of the can and joining the rest of the air around us. It's difficult to see that because we can't see the air, but that is indeed what's happening. So, as we heat it up further and further, you're going to start to see a little column of steam come out the top. Now, once we return the temperature back to normal conditions, those particles will go back to being as close together as they were at the start. However, a lot of the particles already escaped our container because the higher pressure of the hot air pushed them out the top. So what happens when I return it quickly to room temperature is the particles go back to their previous pressure, maybe even lower because of the cold water, and there are much fewer particles in the can than when we started. And what that means is there's less pressure inside the can. And that should be able to show us exactly the kind of effect that all that air pressure can have on top of us. We're almost there. If you've ever noticed people talking about scuba diving, there's a limit to how deep you can go because there's so much pressure from all of that water squishing down on top of you. It's the same with the air, it's just like I said, we don't really notice it. All right, we're getting close. Now you can see how we're getting some steam coming out the top. So what I'm going to do is on the count of 3, I'm going to take our can, turn it upside down into our ice bath, quickly bringing the temperature back down, and we should see what the air does to this low pressure system. All right, you ready? Let's see if this works. 1, 2, 3.
Oh, I blinked.
So not only did we do a fairly good number on the can, there's a bunch of water that got pushed in from our water bath into the can, okay? So when someone goes too deep in the ocean, this is what happens to them as well. Interestingly enough, if you take a deep ocean fish and bring it up to the surface, the opposite thing happens. Instead of squishing in, all the guts erupt out of it, and that is the end of the deep water fish.